Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone.
Morning.
Before starting our activity, it will be good to pray first. Let's pray together. Finish. I will check attendance first. Okay. Asbi, Alvin,
I'm here.
Padlan,
Yeah.
Zalal. Okay. Alhamdulillah everyone is present today. Okay. Have you ever thought about why a table moves when you push it? Or why when a bicycle is moving and we brake suddenly, our body is thrown forward? All of this can be explained by Newton's laws. By understanding these laws, you will know how forces act on objects around us and how the laws of physics are very close to our daily life. So, let's learn with enthusiasm because physics is not just in book but also real in life. Okay, after our learning together today, you are expected to be able to 1. Explain the content of Newton's first, second, and third laws in your own words. 2. Give example of everyday occurrence that correspondent to each law. 3. Solve simple problems related to force and motion. Okay, we move to the first material, Newton's first law. Newton's first law, also known as a Newton inertia, states every object will remain at rest or in uniform motion in a straight line unless acted upon by an external forces. Now, this law states that objects tend to maintain their states. 1. If an object is at rest, it will remain at rest. 2. If an object if an object is in motion, it will continue to move in a straight line at a constant speed. 3. A change in state only occurs if an external force acts on the object. 4. The property of an object that resists a change in motion is called inertia. Here are examples. A table does not move even when blown by the wind because the mass of the table is large enough and there is no force strong enough to change its state. 2. A toy car continues to slide on smooth surface, and if we push a toy car on a very smooth floor, the car will continue to slide because there is no significant force, like friction, stopping it. This shows that an object in motion tends to stay in uniform motion in a straight line.
Have you ever wondered why when we push a heavier object we need more force? So let's learn together. Newton's second law of motion says that the amount of force applied to an object effect is its speed. For example, when I push the board, I have pushed it harder. The speed or acceleration of an object also depends on its mass, whether it's lighter or heavier. If I push the seat with the same force I used to push the board, the seat will move faster than the board because its mass is lighter. There are 3 elements at play here: acceleration, force, and mass. the amount of the material an object is made of. The length of an object depends on its mass. Mathematically, it can be written as force is equal to mass times acceleration. Okay. For example, the board has mass at 7 kilogram, and I use the acceleration 2 meter per second square. So the force I use to push the board is 14 Newton.
So after the video about the examples, we can draw like this. And let's say that this is a bar on the stairs and this is me hanging on it. So we might be wondering, why did I fall down right here? And maybe it's because the slide is going down, but that's not the problem. Because if it's about gravity, I should fall down like this, not like this. So how to imply the Newton's second law on this problem? First, we should draw something called free body diagram. It helps us to imagine more about this formula. So we should draw a diagram, Cartesian diagram, like this. We know that this is weight force equals to mass times gravity, and here there is something called normal force. Normal force is usually equal to weight force because I didn't go up or go down, so the F in y direction is 0 because the only way I go is go down like this. And then so the normal force is equal to mass times gravity, but you know that there is an angle here, so we should use some trigonometries. In here we could use cos theta, and here in x direction there is also weight force, but here direction is changed because the weight force is here, and we should what's it called, mirror it in here. And we also use trigonometry, and it's become mass times gravity times sin theta. So this is the force that caused me falling down, and we know that F equal mass times acceleration, and because this is force and this is force, we could write it like this. We can eliminate the mass, so there is acceleration equal to gravity sine theta. Let's say that the theta is here 30 degrees, and we could calculate the acceleration that happens on me like this. Sin theta is 1/2, so the acceleration is 5 miles per second. So how about the force on me acting in here? We also could use that this. Let's say that my mass is 40 kilogram. So the mass when I'm going down in the stair is 200 Newton. Thank you. So my friend has demonstrated a force acting on a flat ground. So what about a force acting on ground like this? Let's check it out. Come here. So theoretically, if I land on here, I will slide down, right? So let's check that out. We go through. Oh.
Okay everyone, here I and Zahra will discuss Newton's third law. Firstly, we have listened to the explanation related to Newton's first and second laws. So, what is Newton's third law? Does anyone know what Newton's third law is? Okay, we will discuss it together. Newton's third law states that every action produces a reaction. This law is called the law of interaction or the law of action-reaction. This law describes the important nature of force, namely that force always occurs in pairs. If a force is applied to an object A, then there must be another object B that applies that force next. If B applies a force to A, then A must apply a force to B. That is the same size and in the opposite direction. Okay, next part an example will be explained by Zala. Please go.
Okay, thank you Asbi. To help us understand Newton's third law better, let's look at some real life example. The reason that the cap bounces because the board applies the same force opposite direction to the cap. Next, when we swim, as our hand push the water backward, the water pushes our body forward with an equal and opposite force. That what allow us to move through the water. So, in every interaction, there always an action and a reaction force that are equal in magnitude but opposite in direction. That the essence of Newton's third law.
Okay guys, that's the discussion related to Newton's third law. Well, it has been explained regarding Newton's first, second, and third law. Is there anything you want to ask first? Do you understand to the explanation? Okay, to test your understanding later at home, you can do this question, okay? Okay, this is the question. That is for today meeting. See you in the next class. Stay enthusiastic and don't forget to do your homework. And thank you. Wassalamualaikum warahmatullahi wabarakatuh.